This last section we're going to talk about what I talked about in the first video, which is the idea of Pythagorean triples. These are numbers, combination of numbers that always give us a right triangle. And the two I said to remember for sure would be 3, 4, 5 and 5, 12, 13. If you recognize the pattern, then all you need to do is write either 3, 4, 5 or 5, 12, 13, and then write what the answer is. The other two that are in the book are 8, 15, 17, and 7, 24, 25. And again, the reason why these work is if I do 8 squared, which is 64, and 15 squared, which is 225, adding those together I get 289, which is the square root. A square root of 289 is 17. And the same thing happens here as well. So if we look at this, 24 and 10, well, this looks like 5 times 2. And if that's 5 times 2, then this is 12 times 2. Then this has to be 13 times 2. So the short way of doing this would be to say that it's a 5, 12, 13 triangle. And again, you just have to look for that pattern, because I see a 5, I see a 12, and I see a 13. Therefore, we'd be able to say that x is equal to 13 times 2, or 26. If you don't recognize that, what you'd have to do is say x squared, because x is the hypotenuse. That equals 10 squared plus 24 squared. So we get x squared is equal to 100 plus 576, I believe. And then if we add those together, we get 676, and square rooting those, we get our x equals 26. But I would suggest this method whenever possible. And these are the only two that I would really memorize, because those pop up a lot. So again, using a Pythagorean triple, we see it's 5, 12, 13, so it's 13 times 2, which is 26. Using the Pythagorean theorem, we plug in 10 and 24, we get 100 plus 576, and we get x squared equals 676. Square rooting both sides, we get 26. For this second one, again, we want to do it using Pythagorean triples and the Pythagorean theorem. If you notice, this is 3 times 3, and this is 4 times 3, so x has to be 5 times 3, or 15. That's the short way using a Pythagorean triple. If you're not using a Pythagorean triple, the hypotenuse here is x, so we'd get x squared is equal to 9 squared plus 12 squared. So x squared is equal to 81 plus 144, and x squared is equal to 225. If we take the square root of both sides, we get x is equal to 15. So that's the other way to do this problem. Thank you. And for this last one, hopefully we can recognize that this is 7 times 2, and this is 24 times 2. So this becomes 25 times 2 because it's a 7, 24, 25. This doesn't appear that often, so it's not a big deal. Then what we'd do is we'd say x squared is equal to 14 squared plus 48 squared, and x squared is equal to 14 squared, which is, I believe, 289, but I'll type it in. Oh, sorry, completely wrong, 196. And then 48 squared is 2,304. So then if I move that down a little bit, I get x squared is equal to 2,500. And square rooting both sides, we get x is equal to 50, just like it would be up here where x is equal to 50. And that's it. Thanks.